Bueno, es un placer para mí este, contar con la participación de todos ustedes. Un honor que hayan aceptado esta invitación. Hoy vamos a tener una conferencia que nos va a compartir el ingeniero Ken Nelson. Ken Nelson es ingeniero principal en UL Solutions. Eh, Forma parte, o sea, él es experto en todo el tema que tiene que ver con aires acondicionados, ventilación, calefacción y el tema de calderas. Ya Ken ha compartido con nosotros en otras oportunidades una presentación similar. Fue invitado por el CIEMI, por el Colegio de Ingenieros en Costa Rica. Tuvimos la oportunidad de compartir allí. Y él, digamos, es el Big Boss cuando hablamos de caldera y normas o reglamentos relacionados con calderas. Entonces, él nos va a compartir un webinar que se llama, le ha puesto el nombre de Estándares de UL que aplican a la seguridad de calderas. Kendi y yo bueno, él pertenece al comité de normas, de vicepresidente del comité de la norma CSD1 de ASME, que tiene que ver con sistemas de combustión y seguridad de calderas automatizadas. Somos compañeros en la NFPA 85, que tiene que ver con sistemas de control de combustión y seguridad de todo el tema de combustión y calderas. Este, la diferencia entre el CSD1 y el 85, la NFPA 85, es un tema de capacidad de producción de vapor. Este, y bueno, Ken también ha sido, digamos, la persona, contacto nuestra para toda Latinoamérica para facilitar todo este tipo de información. So, Ken, I leave you the camera and microphones for you to start your presentation, your seminar.
Perfect. Thank you, Carlos. Muchas
Oh,
gracias.
thank you. Thank you.
So today I have the webinar split into two different sections. So the first section, we will cover a discussion about the different standards that are used for certifying boilers. And we'll talk more generically. So I know that in the Latin American region, there is a lot of doubt about what standards shall be used, how to understand these standards. So we'll start with a very broad discussion about how certifications are done. What do we do in order to get a certificate for a boiler? Then we'll talk about the process for the technical committees. So a very important thing for the LATAM region is to understand that even though these standards are written for the United States, globally, we receive participants that can submit their concerns, submit what incidents are relevant to you, what things do you see happening in your factories, in your applications where these are being applied. And then we'll talk specifically about what the main standards and updates that have been recently done to those standards. This all covers any type of boiler, whatever the fuel, whatever the process that's used for that fuel. And then specifically, I have a second section that is focusing on the changes that are happening across the globe for decarbonization. So I cover each of the main areas where we have these transitions into different plans. So I know in LATAM, it's no different than anywhere else in the world where there is not one single source. We are looking for how we can achieve this decarbonization. So we'll talk a little bit about each different fuel type and what options there are for transitioning into a lower carbon methodology for boilers.
Good.
So the first section here, starting with evaluation and evaluation for the certification. What are we doing to get these products certified? Historically, the origin of UL, of Underwriters Laboratories, of my safety organization, started based on the Columbian Exposition in Chicago back in the 1890s. So in 1893, there was a World's Fair in Chicago, and UL's founder, William Henry Merrill, had been tasked with helping to ensure that we would protect the public, that we could ensure that there is no safety issue with these new electrical lights that are being brought into the public space. So since then, UL has been tasked with evaluating systems, evaluating things like boilers to ensure that we do not have a risk to the public. The way in which this is done is looking at specific essential concepts, and it generally comes down to 3 different areas. So we have risk of fire, electric shock, and functional safety. To check these areas, we have tests in specific areas. So on a boiler, we're particularly looking at the heated fluid. So are we dealing with water? Are we dealing with steam? Those change the requirements that apply and what severity level we have. So when we look at the specific requirements for each standard, one thing that is universal, regardless of it being a UL standard, an IEC standard internationally, a CSA standard, they all are looking at that risk. What is that risk to the public? What can we do to prevent explosions? What can we do to prevent scald hazard? There are different levels of safety that are required depending on the severity. And the media itself that is used for heating. So are we dealing with an electric boiler that has a high voltage and large amount of current that could create a potential hazard? Do we have gas or oil, which could have an explosion risk, etc.? This presentation focuses mainly on the UL style standards, the Underwriters Laboratory standards. International standards like ISO standards, IEC standards, they have very similar constructions. But in any of these, it's important to understand where to find the critical parts as to how to use them. So all of these standards will start with an introduction that gives us an overall scope of what the product is being covered by this norm or this standard, what definitions we have that are used throughout the standard so we have a common language to address the requirements, and what components are used that are referenced by the standard. So very common in boiler standards, we will look at things like requirements for pressure vessels. So in any of the UL standards, we will refer to the ASME requirements for the pressure vessels as an example. The next section talks about the construction, what components are used, what is the buildup of the system. So we're looking at things like protection against access to live parts. What enclosures are there around these live parts to prevent the users, to prevent the service personnel, the boiler operators from having casual contact to these live parts? How do we keep the pressure vessel from having a potential explosion risk? What requirements are there for pressure relief devices, water level switches, burner controls? All of these items are described in the construction section for the minimum construction requirements that apply to the system. Then we have the performance section of the standard, which has the actual tests where we are functionally operating the boiler and then making sure that we're looking at things that are covering both the fuel. So for example, burner operating characteristics, combustion tests are critical tests for any gas-fired appliance. So this is not limited only to boilers, but for any gas-fired equipment, whether it's forced air heating equipment, whether it's cooking equipment, they will always have this critical series of tests to make sure that we're evaluating the combustion properties. For these types of tests, we have specific compliance criteria. For example, looking at carbon monoxide. So carbon monoxide being an odorless, colorless, tasteless gas, we need to have the tests for the system ensure that we do not have a release of this gas into the occupied space. For boilers, looking at a low water cutoff, looking at the water level, is very critical to us to prevent explosion. When we look at the specific standards, you can see that when reading those, different standards will have different approaches. So it's very important to know your application. Some boilers will require a low water cutoff, whereas some, especially smaller residential boilers, can have an alternative where we're mitigating this risk. We're mitigating a failure of this low water condition in other ways. For example, for small residential boilers, it can be an option to do a dry fire test where we operate the heating elements and have no water in the boiler and ensure that we have a safe condition. But commonly, you'll see that low water cutoff as one of the critical elements we're looking at in the control system and physically testing that in the boiler. Does the low water cutoff operate appropriately to de-energize the heating means? And or can we prevent that from being a required construction due to the results of that test? A critical part of a UL certification. So UL is not only interested in doing the tests on a system as it's designed, we have what we call follow-up services or surveillance. So a UL mark is associated with not only the type certificate or the evaluation of that product associated with the tests to ensure the design is safe, but we also conduct inspections at the factory and ensure that the continued production of that boiler is the same as what was tested. So the output of one of these certification evaluations confirms that the actual product, exactly as it was tested, is what is continuing to be produced. And that assurance is verified by that UL mark applied to the product, matching that certificate on this continuous basis of these audits that are done at the factory 4 times per year. So any product that is continuing to be produced with the UL mark, and this also is not just boilers. This is for boilers, this is for heating equipment, this is for household appliances, industrial equipment, anything where you see the UL mark, that product is inspected at the point of manufacture 4 times per year. When we look at UL standards, I mentioned a couple of examples of ISO or IEC and other international-based standards. For the LATAM region, it's common to see both, especially in South America. I've seen where the building operator, the building designer, builder typically will specify, hey, if we're going into Argentina, do we want to have it comply with the EN 298 standard for a burner control, or do we want to comply with UL standards? An example for, or an advantage of the UL specific standards for the LATAM region specifically is that these have been written on the basis of North American requirements. So looking at Mexico specifically, we know that the electrical system in Mexico is the same frequency, the same voltages as what we have in the US. Moving down into Central and South America, very similar. And quite importantly, when we're looking at electrical codes, we see a very frequent adoption of the US National Electric Code, the NFPA 70, in regions in LATAM, which maps very well with it. The requirements work very well with the UL standards. So this helps that not only for local market access for designing and selling and installing equipment in Latin America, but when that equipment's designed in Latin America and then sold up into North America, sold into the US and Canada, this gives you a single source, which then allows those products to be sold throughout the region. One thing, so here I can say I covered that was the concept here, right? Instant market access to North America. Another advantage is simpler requirements than those based on the IEC. So when we look at something for a gas appliances regulation certificate, that's something underwriters laboratories can do as well. I also participate in gas appliance regulation certificates. However, the process for achieving that certificate is more complicated. There is a simpler process that can be used by following the UL standards. So for countries which adopt the UL norms, we find that that offers a faster path to market access. It's more closely aligned with the National Electric Code. So there are areas, specifically in Mexico, this can be a bit of a conflicting situation because of NAM. So NAM oftentimes will adopt electrical standards from the IEC, but then there needs to be differences added to accommodate NFPA 70. So a very complex situation, but the purpose of raising this point here is when considering standards that are used in conjunction with the National Electric Code NFPA 70, the UL standards do offer a very direct path of comparison, since for many years, these requirements have been based on that connection. So next, I want to talk briefly about the technical committee process. So I put a lot of detail in these slides and give specific examples, but I think I want to focus mostly on the direct standards. That's the title of this presentation. The goal is to give a view into the specific documents for boilers, since we're here to talk about boilers. But any standard that's developed by a consensus process follows this plan. So the idea is, even though UL's name appears on the standard, it's not something that myself and my colleagues just have a meeting to draft and write these requirements. These requirements are written as a result of the technical committee that meets to prepare these requirements. Why this is important, especially for LATAM, is for the LATAM region, is that you have a voice in these standards. Just because it's a standard written as an American national standard, and for example, UL 795 is the UL American national standard for gas-fired heating equipment and boilers, but it can be used in any country that chooses to adopt that standard. So what this means is, for anyone within Central South America, you have the ability to draft a proposal to make changes to the standard. The goal of the standard is, I mentioned in the very first slide, right, that UL's history is electrical and fire safety. So we want these products to be safe. Your experience on what things are important to your region help make the standard stronger for everybody. So on this part, the main point is basically that the technical committee has different parts of industry that also includes different countries. We actually have a specific group for international users of the standard. So an advantage to everyone on this call is it's oftentimes difficult as a producer of a product to join a committee that's already well established because there already are many producers on that committee. But in most of the UL standards, we have either 1 or 0 members that are international users. So everyone here on this webinar would be a candidate that would be likely to be approved as an addition to the committee, since an international user provides a different voice, provides a different background, provides a different use case for boiler standards. So this is different than many other webinars I have where I say, well, if you're a boiler producer, we already have a full list of boiler producers. We need other voices to join the committee. So for those here, if you do wish to join the committee as a voting member, that would be something that would be a very likely thing to be able to do. But you do not need to be a member of the committee to submit proposals. So on the slides here, I give some background with some specific advice how to do this. For any UL standard, the website is the Collaborative Standards Development System. So it's csds.ul.com. And basically, when you log in, you can submit a request. You click Submit Request. You select the standard. So a boiler standard example would be UL 795. And then you can describe what you would like to add to the standard. So one example, this actually is an active thing we still would like to do, but have not had the time to do it. There's a discussion about adding the requirements from UL 2096, which is for equipment with flue gas recirculation, if I could say that. It's difficult even in English. Flue gas recirculation, or FGR systems, have a different standard that's outside of the requirements of 795. So as an example, to make a single standard which covers both boilers with and without FGR, it could be proposed to combine these items into the same standard. Any proposal must be processed by the committee as long as you follow certain rules. So those rules include providing a detailed justification. So what the reason for this request is, including supporting information, having the changes shown, so having track changes, for example, having underlined new requirements, strike out the ones you are removing, use the actual text of the standard. If the request is to say, for example, we want to remove a requirement for low water cutoff, that would not be accepted because there's not the detailed request giving what the proposal is in the text of the standard, actually adding or removing direct requirements. It's important to ensure you're using the latest edition of the standard. When making a revision, we always revise from the most recent version. Some things that are more administrative: we cannot have any copyrighted material. So for example, if it's an individual boiler company that has some patented and intellectual property related methodology, we cannot put anything that's a company's or individual's methodology or protected information in the standard. It has to be public information, since the goal of the standard is for any company to be able to follow these requirements. An important, I guess another administrative thing, but another important administrative thing is language of certification specifically. So UL would like if we say that everything has to be UL listed, but that's not a standards requirement. That doesn't come through the norm. That's up to the authority having jurisdiction to be accepting and approving a specific installation. But the standard only will tell you what you evaluate the product to. So here, the terms listed, follow-up service, having a specific labeled, that's something that isn't a term that we would not include directly in the safety standard. Where you will see these terms is in the field code. So when you look at NFPA 70, when you look at CSD1, so Carlos had mentioned that's the team that developed CSD1, the Combustion Safety Devices for Automatically Fired Boilers Committee, is a committee that I am on. And in that group, we do say must be UL listed. There shall be a UL listed control there. But in the boiler requirements themselves, we do not reference the level of certification needed, only the fact that there must be an evaluation done to certify the product to the standard. And then the field code, the authorities having jurisdiction, they will decide what certification level is needed on those products. Finally, it's important to use specific language. We want to say shall. We want to use normative language, as they say. It makes sense, right? So the Spanish word normas, right? Standards, norms, it's normative. So you shall have a low water cutoff when certain conditions are met. Saying something like should or can, that would imply that that's optional. So anytime a change is made to the standard, the goal is to ensure that we're requiring this for safety, so the normative language must be used. I put a couple of links to the written text of these rules. So for ANSI developed standards, for the American National Standards Institute, they have essential requirements that must be followed. For UL, we adopt the ANSI rules and have specific technical committee requirements. So I placed some links here where you can find these informations or find this information. But again, it's required that the committee will review and respond to any such proposals that are following these rules. So now that we've talked all about the general things, how to evaluate a product, how that standard gets published, what are the actual standards we're using here? So I split into a couple of slides here and put it by the fuel type. So when we're looking at the certifications, the product certification is organized by what the fuel is for that boiler. So if we're talking about a gas-fired boiler in the US, we will commonly use UL 795, which was just recently published as a binational standard with Canada. So in the past, we had to use different CSA or CGA standards and apply both to the single product. But now we can incorporate the single document and have an evaluation done once, which will cover us both for the United States and Canada market. This I'll come back to in more detail on my discussion about the decarbonization. But it's important to note that UL 795 is one of the first standards that incorporates up to 25% of hydrogen that can be used in certifying the appliance. Talk more about that later. When we're talking electric-fired boilers, then UL 834 is the standard that we would use with that. There's still a process in progress, which will have some modifications that will help to make it more consistent with standards like UL 795, but the essential requirements are all staying the same. So the requirements of how we list an electric boiler are not planning to change. We are planning to add some additional tests for things like outdoor use boilers, marine use boilers, based on some of these other requirements. Things for connecting the product to the internet. This is something that is being developed as horizontal standards for all products and are starting to be introduced for boilers as well. Where do we draw the line? Where do we say it is acceptable to have connection to the cloud, connection to apps, connection to internet monitoring, versus what things are restricted? For example, downloading safety software, updating software on boilers. There are modernizations happening now where we are incorporating new requirements for this. One thing that actually I didn't make it in the slides here because it just happened last week that UL submitted a proposal to the controls standard to 60730. So I did mention that on this slide here in general, but there is a new proposal for cybersecurity requirements. And we are proposing that all controls, whether they are safety controls or not, will have a requirement for additional cybersecurity evaluation anytime they are connected to the public network. So this is more on the control component side. That would be a separate webinar, but be aware that there are changes happening that will affect us with the boilers, with the industrial equipment based on these control components within the products. A very common discussion point now for decarbonization is heat pumps. There are new requirements. So this actually is in the editorial phase now for revision 1 of the 4th edition of 60335-2-40. And basically these requirements are continuing to add things from the legacy standard. So it's making it again more of a US and Canadian based standard. And a very important key if you are a customer that is working with heat pumps, if you are dealing with vapor compression for heating of water, these numbers here are very important to you. So when the refrigerant charge is less than what the standard defines as M1, which that's a complex topic that could be I do a 2-day webinar just on this standard alone. But specifically for flammable refrigerants, there is a particular charge limit that requires these refrigerant detection systems to be used and adds a lot of testing requirements, cost, and expense to the product. As an example for some common refrigerants for R32 and R454B, which are commonly used for air conditioning type applications, that limit is about 4 pounds or about 1.8 kilos. So know that if you have a product which has a key to this is being used indoors. So outdoors has other requirements. If it's a chiller, so something like a centrifugal chiller, medium voltage, this part does not apply. This would be for systems used within a building, in a machinery room, inside of a home, inside of a residence, inside of a commercial application. Anytime indoors you have more than this charge amount, there are additional requirements for the refrigerant detection systems. For oil-fired boilers, the biggest change here is for a change to the control scheme. And this requirement's in the process of being updated. So this data is still correct, but further discussions with CSA, who publishes this 140 series, the B140 series, so including B140.0 and specific for oil-fired boilers, B140.7. We are talking about extending the length of time by which you have to transition to this. But the change was to only permit control systems that have been evaluated to this IEC-based standard. So that can create a lot of rework in recertifying oil-fired equipment to meet the new Canadian requirements. So now with 15 minutes left in the original hour, I want to give some quick introductions specifically to areas of decarbonization, and then I will open the floor and leave some time for questions and additional discussion where we can go back to previous slides and talk about more background or more detail if needed. So I split into 4 different fuel types where we're focusing on decarbonization. A very simple one is using electricity to fire the boiler. So UL 834, I give some specific points on here on what products are covered under this standard. A difference between this UL standard and others is that UL 834 covers both low voltage equipment as defined by the National Electric Code by NFPA 70. So we have up to 600 volts and medium voltage. So boilers which are supplied from the transmission level at, say, a 13.8 kilovolt level, those also may be listed and labeled. They may be evaluated to UL 834. We can cover 3 different types of boilers per the scope. We have high pressure boilers above 15 psi, where the temperature is above 250 Fahrenheit or 121 C. We have hot water and low pressure or just low pressure boilers. So if we're less than that 250 degree Fahrenheit, we can be listing that as a hot water boiler. And then miniature boilers. So all of this, I could go into more detail, but I think we all can read this. This is all aligning with the requirements for ASME. So when you look at an ASME stamped boiler, they have the different options for whether it's a hot water boiler, whether it's a miniature boiler. UL 834 adopts these definitions and allows the listing and labeling of these types of boilers, whether they are used in commercial industrial spaces or residential. Biodiesel is something that has recently been allowed as an option up to 100% biodiesel. And this is due to the requirements published in the oil-fired burner standard. So up until 2022, we did not have the specific test requirements for this. And the issue is a little bit of a chicken and an egg situation where we needed to have components which could be used within the product itself. So our pumps, our valves, our gaskets, specifically things like gaskets, when we add more organic components to the fuel, the same issue we've had with the oil-fired equipment for boilers and burners is as we had with the gasoline for vehicles. So I know very common in South America, very common in Mexico, where you have your biodiesel and your ethanol, right? So ethanol used in fuel, same issue. Now we have an absorption of more water that is in the tanks going through the pumps, and using this organic material creates a highly acidic a much higher acidity to that component. So the change to biodiesel requires that we do additional testing. And we started with a lower level. So 6 to 20% biodiesel has been in the standard going back about 10 years. But the B100, the 100% biodiesel, required that first we update the valve requirements. And so for automatic valves, manual valves, we have UL 428B, UL 842B. And we can do this by testing with the either FB25A fluid, the aggressive test fluid, or using the B100A fluid defined by ASTM. So it's very important that for biodiesel, we are able to certify this equipment because there are ASTM specifications for this. So this is something that becomes a challenge for biogas, and I'll come to that in a few slides. But first, I want to give a quick summary of hydrogen. So for hydrogen admixture, I give a few examples here of particular programs that are being used. So we have the THIGA program in the EU, in the Netherlands. We have RVO is doing evaluation of 30 to 100% hydrogen in Leeds in the United Kingdom. There's a viability study that was done back in 2017 that was covering up to 100% hydrogen admixture. But in North America, what our biggest barrier is right now is the fuel gas code. So NFPA 54 does not currently allow us to have a hydrogen admixture with the caveat that, or with the exception that up to about 5%, the product standards have said is equivalent to natural gas, but going above 5%, the fuel gas code does not describe that today. So this percentage of hydrogen is what is currently limiting us from evaluating and testing these products today. What UL can offer is for customers that wish to design the products to be ready for this change, we have what we call a marketing claim validation. So this is not a certification. This is an evaluation that prepares us for when that field code is updated, we can test the product now. So we have two different options. The ready option is saying that the product will work with hydrogen, but you need to add a kit to it. So this is very similar, and those of you in maybe the mountainous regions down in Mexico or in the Andes and Chile and Argentina, you know that when the products for combustion are used at those higher altitudes, we need a high altitude conversion kit to adjust the orifice to work in that higher altitude with that lower oxygen content. So same principle here. If you have an existing propane-fired or natural gas-fired burner or boiler, and you can add a kit, which will allow it to be used with up to 20%, 80%, 100% hydrogen, we can evaluate that. Or if the same exact product can be used with both a standard natural gas or one blended with hydrogen, we can test it without the conversion kit. So different options that prepare us for when the fuel gas codes do get updated, then you can have products that are already ready to use. The last one I want to talk about is biogas or digester gas. And unlike the biodiesel, the struggle we have here, and I put some specific examples to some discussions we've had in CSD1 to allow the controls to be used in these biogas operations. And the problem we have is there is not a public standard for that actual gas itself. So we know that when you have a swine farm or when you have some landfills and different operations where you can draw the methane off of that process, you can burn it. But just like I said with the biodiesel, we need to have tests that'll cover the higher acid content, the other non-combustibles that are associated with that. How do we deal with the added hydrogen sulfide content when we have these organic materials? So there is a significant barrier today because we do not have the listing, we do not have the certification for that equipment to allow it to be referenced in the fuel gas code. So a very, very high amount of information. I tried to give some background and details, not just in the slides, to give some talking points, but I did want to leave a few minutes so we could have some open time for questions. So with that, go back to Carlos, and I don't know if we have questions in the chat, if we'd like to open it up to the group to ask some questions before we clos today.
No, we don't have any question in the chat, so los micrófonos están abiertos. Si alguien tiene alguna pregunta que hacer, alguna consulta, algún comentario para el resto del grupo y para Kent.
It's a lot of information, so it might take some time to digest.
Yeah. José Castillo has a question.
Yes.
José, por favor.
Okay, thank you, sir. Can you hear me?
Yes.
Oh, yeah. Congrats for the presentation. It's very great. I understand this is very important for us. But my question is, in the case, I think use biogas in the boiler, for example, the simultaneous combustion using biomass with biogas. What is the advice for to use the biogas in this combustion with respect to have good security, good components, and good materials? You got it?
Yes, I did. Very excellent question. Here, let me go back to that slide here. So in practice, I've heard of many installations where this is being used today, and the focus is, like you said, on the components. So I've heard from valve manufacturers, I've seen presentations from them that they will use their highest grade stainless steel valves only in those applications. They will make recommendations for what types of components can be used on that fuel train. But the biggest challenge today is this part here, where that's not something that's part of the existing listing. So my advice would be that this is something that always should be checked very early with the authority having jurisdiction. So whoever is the inspector for where that building or process will be built, they are directly approving that. And I know in the US and Canada, because there is not a global standard for this, or there's not a national standard even for this, it's each inspector making the evaluation of this. So my hope is, and what I know we are pushing for, I've heard of some experts that are currently working with ASTM to, I'll go back to the biodiesel here. So an ASTM specification, if we can say, okay, we drew some biomass effluent, we took this gas which was created from this process, and we can compare it against a certain known, then that gives us a very clear test path. So today, it's really about the authority having jurisdiction and confirming their requirements. Do they require a specific grade stainless? Do they require a specific replacement plan for maintenance? I've heard some valve manufacturers will say for biogas, they only warranty the part for 6 months, and you have to replace it to ensure that it does not get damaged by those acids. So for now, it's direct collaboration with the component suppliers, and then confirming that that gas train has been validated either in the field or through a approval process. For the future, I would ask that we help support getting a definition for that gas and giving a boundary for what those components would be, so that we can say, okay, if there is less than X percentage of acid, we could sample that periodically, and then we have a very clear way we can certify the parts and products for that application. Does that answer your question?
Yeah, yes. Thank you, sir.
José, una pregunta. ¿De qué país nos acompaña?
I'm from Colombia.
Okay.
From Colombia. Here in Colombia, we had a lot of boiler, especially in the different kinds, using the coal, using the gas.
Yeah.
And in sugar sector, there are different boilers on different capacities. But the future is to include the biogas with in the combustion, in the boiler combustion, to replace the coal. We are working in energy transition too.
Good. Welcome, José. ¿Alguna otra pregunta? Any other question? ¿Alguna otra pregunta? Andrés Jiménez, Glenda Gutiérrez. Paulina. ¿No hay preguntas? ¿No hay más preguntas? José Trejo, por favor, díganos.
Gracias. This question is in regard of the industrial and commercial boiler safety. While performance standards in Mexico, like NOM 20, is focused on efficiency, and your standard is made in safety, it seems. For your perspective, what is the most critical failure mode in boiler system that modern UL standard are designed to prevent?
Excellent question. So In my experience, the most common failure we've seen recently or I'd say there's probably two areas. So one is for gas-fired boilers when there are issues in either incomplete purge or an inaccurate change to the ignition stage, which causes an explosion of the uncombusted fuel, or issues with a low water cutoff. So that example I gave talking about low water cutoff level controls, there are many issues in the field that occur with the level of the water, creating flashover to steam and causing either nuisance issues where we are discharging through the pressure relief, or at the worst cases that go to explosion. In many of these cases, in all that I am aware of, the ones that have gone back at least through the US courts and have been brought back to UL, they were deemed either as maintenance issues or issues with replacement components that were not done correctly. And this is an area where the field code has been making many changes to have clearer lists, clearer inspection lists, clearer inspection processes. And UL is working to help with coordinating that to make it easier for the inspectors to know what is a correct part, which parts are appropriate to put in that case. But in my experience over the last 17, 18 years, and from my colleagues that trained me going back to, say, the 1970s and 1960s, generally the standard has been focused on that combustion process itself. Things like electric boilers, there are occasionally failures of elements. That does create those dry fire tests and tests to validate the insulation on those. But typically it would be, I'd say, in those areas. And the safety standards, we're looking at always looking at the steam, always looking at potential explosion on the water side. And then on the fire side, we're looking at that combustion process and ensuring that we always have a clear, free air, open air, fresh air before allowing the valve to open, and then ensuring that we maintain that flame during combustion.
Got it. Thank you, Ken. Appreciate it.
José, ¿de dónde nos acompaña?
México, Ciudad de México.
Oh, bienvenido, bienvenido.
Gracias a ustedes, gracias.
¿Alguna otra pregunta? ¿Algún otro comentario? ¿Algún otro aporte para el grupo y para Kent? Aprovechen que Kent puede recibir información para considerar en las próximas ediciones de Estándares, ¿no? Entonces, si tienen alguna duda, algún comentario que consideren importante, aprovechen el momento. And it seems that there are no more questions. The two questions we have were very, very interesting. I don't know if you want to say something else or just muchas gracias.
Nothing major other than just that I look forward to collaborating and working with you all further. Let's continue this discussion. Any other questions, any things that come up, Carlos, please reach out to Carlos, reach out to me. Let's keep this discussion going, and
For sure.
we're here to help and make sure that we keep these products safe and continue the updates, and we'll work with all the changes. So especially I appreciate that feedback on, sugar processes and things that are happening to replace coal. We know that's needed. This is an important step to help the industry. So
Yeah.
We are here to help. That's the closing message from me. Thank you, Carlos.
Thank you for your gentle open doors. Ever I contact you. We do really appreciate that. So I'll contact you again because it is my intention with this initiative of let's talk about boilers to to start to promote regulations, to promote the use of standards. And for sure, I will contact you again, and I disturb your busy time with some other subjects, some other points, to talk with Colegio de Ingenieros, or to talk with particular regulatory bodies. So I consider this is very important. Yeah. So, entonces, bueno, les agradecemos mucho a las 22 personas que estuvieron acompañándonos durante este seminario. Si no hay otra pregunta o otro comentario, pues paramos aquí la presentación, en la reunión, y les agradezco a todos por haber estado presentes. Sí.
Muchas gracias,
todos.
Carlos, y a todos ustedes. Muy bonita y muy satisfactoria la exposición.
Gracias, Carlos. Bueno, Nelson, let me introduce you, Carlos Navarro. Let's take advantage of this. Carlos Navarro is coordinating the future regulation of boilers in Peru. So for sure we can share maybe another meeting with them and collaborate with them to do the best regulation they could do.
Excellent.
Bueno, me pulsan una carta y está acá, en donde nosotros estamos ahí considerando la autoría del congreso. Eso también, ahí también está que les copia, para que se quede.
¿Quién está hablando? Well, so thank you very much for all you and for you all. And well, let's see in the next meeting. Okay.
Gracias también.
Thank you. Thank you, Ken.